Hello friends, now this is lecture number 5. In this lecture, I will discuss the derivatives of inverse function and the examples which has been asked from the exercise 1.2 in the board examination. First, I will discuss the theorem and then I will take the examples. Now, let us start. If y is equals to f of x is a differentiable function of x such that inverse function x is equals to f inverse of y exists, then prove that x is a differentiable function of y and dx upon dy is equals to 1 upon dy by dx, where dy by dx is not equals to 0. And this is the theorem. It has been asked in board examination number of the times, and that's why this is very important. Now let us start to prove this. Proof: let delta y be the increment in y corresponding to an increment delta x in x. सर्व थेरमच्या जर सुरुवातीच्या ज्या स्टेटमेंट्स बघितल्या तर त्या सर्व सिमिलर असतात, म्हणून 2-4 वेळा तुम्ही जर या रिवाइज केल्या, लिहिल्या तुम्ही, तर निश्चितच बोर्डच्या एक्झाम मध्ये तुम्हाला ते लिहिता येतील. ओके, नेक्स्ट स्टेटमेंट: as delta x tends to 0, delta y also tends to 0. Now y is a differentiable function of x. Therefore, limit delta x tends to 0, delta y by delta x is equals to dy by dx. Next, now delta y by delta x into delta x upon delta y is equals to 1. Delta x upon delta y is equals to 1 upon delta y by delta x. Taking limits on both sides as delta x tends to 0, we get limit delta x tends to 0, delta x upon delta y is equals to limit delta x tends to 0, 1 upon delta y by delta x is equals to 1 upon limit delta x tends to 0, delta y by delta x. Limit delta y tends to 0, delta x upon delta y. As a delta x tends to 0, delta y also tends to 0. That's why I have written here. Next, 1 upon limit delta x tends to 0, delta y by delta x. Now, since the limit in RHS exists and therefore the limit in LHS also exists, and we have limit delta y tends to 0, delta x upon delta y is equals to dx upon dy, and therefore dx upon dy is equals to 1 upon dy by dx, where dy by dx is not equals to 0. Hence the theorem: dx upon dy is equals to 1 upon dy by dx, where dy by dx is not equals to 0, and hence it is approved. त्यामुळे हा बोर्डच्या एक्झामसाठी अतिशय इम्पॉर्टंट थिअरम आहे. नेक्स्ट, now some examples. Hence find ddx of tan inverse of x. This question asked in March 15 and 17. Let y is equals to tan inverse of x, then x is equals to tan of y, where x belongs to set of real number and the values of y lies between minus pi by 2 to plus pi by 2. Now differentiating with respect to y, we get here, differentiate this with respect to y. Here y is a variable and now x is a function. Okay, therefore dx upon dy is equals to, what is the derivative of tan of y? Sec square y. But what is the sec square y? By using the trigonometry identity, त्यानुसार 1 plus sec square y म्हणजे काय, तर 1 plus tan square y, and therefore dx upon dy is equals to, but what is the value of tan y? Tan y is x, and that is equals to dx upon dy is equals to 1 plus x square, and therefore dy by dx is equals to 1 upon dx upon dy, where dx upon dy is not equals to 0. Now the next is Therefore dy by dx is equals to 1 upon 1 plus x square. And that's why the dx of tan inverse of x is equals to 1 upon 1 plus x square. Now again, the same type of the problem, y is equals to sine inverse of x. The values of x lies between minus 1 and plus 1 and equal to minus 1 and also plus 1, and the value of y lies between minus pi by 2 to plus pi by 2 and equal to minus pi by 2 also and plus pi by 2 also. Then show that dy by dx is equals to 1 upon in under root of 1 minus x square. This question asked in March 17 and July 19. Also find out dx of sine inverse of x. Now let us start. That y is equals to sine inverse of x and therefore x is equals to sine y. Now differentiate this again with respect to y. We get dx upon dy, the derivative of sine of y is a cos of y. But we can write this cos y, that is the root of cos square. But what is the root cos square? 1 minus sine square. But what is the sine of y? Sine of y is a x. Therefore dx upon dy is equals to in root of 1 minus x square. And therefore dy by dx is equals to 1 upon dx upon dy, where dx upon dy is not equals to 0. And therefore dy by dx is equals to, we substitute the value of dx upon dy, and that is a root of 1 minus x square, where x is not equals to plus or minus 1, and hence the derivative of sine inverse of x is 1 upon in under root of 1 minus x square. Second question. If y is equals to sine inverse of 3x plus sec inverse of 1 upon 3x, then find dy by dx. This example asked in October 14 examination. Now the solution. Sine inverse of 3x plus sec inverse of 1 upon 3x. Now the see this here again. Okay. Y is equals to sine inverse of 3x plus sec inverse of 1 upon 3x. Now we will convert this sec inverse of 1 upon 3x to the cos inverse of 3x, and we will apply here the formula. See this formula. Sec inverse of 1 upon x is equals to cos inverse of x. Okay. Now see this here. Y is equals to sine inverse of 3x plus cos inverse of 3x. And again next sine inverse of x plus cos inverse of x is equals to pi by 2. And therefore here y is equals to, we will get here pi by 2. Now pi by 2 is a constant quantity. If we differentiate it, its derivative is 0. Therefore differentiate with respect to x. And therefore dy by dx is equals to ddx of pi by 2. And that's equals to 0. Okay. Therefore dy by dx is equals to 0. Now next. Number 3, question number 3. Differentiate cos inverse 3 cos x minus 2 sin x upon root of 13 with respect to x. This example asked in October 15. So solution, let y is equals to cos inverse of 3 cos x minus 2 sin x upon a root of 13. Now we can split up it like this, that is a 3 upon root of 13 minus 2 upon root of 13, and if we take 3 upon root 13, it's a square, plus 2 upon root 13, it's a square, and that square is equals to 9 upon 13 plus 4 upon 13, that is equals to 13 upon 13, that's equals to 1. Okay, now see this here, the triangle ABC. At the angle A, we have treated it, this is the alpha. The sides of this right angle triangle AB is 3, BC is 2, and the hypotenuse is root of 13. We'll define here the cos alpha, adjacent side upon hypotenuse, 3 upon root 13, and sin alpha, 2 upon opposite side upon hypotenuse 2 upon root 13. Now see this here. We can write here that is a 3 upon 13 cos alpha, 2 upon 13 here the sin alpha, and here we will substitute that is a 3 upon 13 means what? Cos alpha into cos x minus 2 upon 13 sin alpha, that is sin alpha into sin x. Y is equals to cos inverse of cos x into cos alpha minus sin x into sin alpha. And now this is the expansion of cos of a plus b, that is the cos of x plus alpha. It means that is the cos inverse of cos of x plus alpha is nothing but x plus alpha, where alpha is a constant. And here if we differentiate this, y is equals to x plus alpha, that is the dy by dx is equals to ddx of x plus alpha. The derivative of x plus derivative of alpha. The derivative of x is 1 and the derivative of alpha is 0. And therefore dy by dx is equals to 1. Now before the next question, these are the expression and their standard substitution. Whenever you have in root of 1 minus x square, the substitution is x is equals to sin theta or x is equals to cos theta. And in this way, these are all the substitution. You have to remember all the substitutions to solve the problems depending on inverse trigonometric function. त्यावर डिपेंडिंग असणारे एक्झाम्पल साठी तुम्हाला या सबस्टिट्यूशन लक्षात ठेवावे लागतील. नेक्स्ट आता इथे बघा, नेक्स्ट इज हियर वी विल अप्लाय हियर दी सबस्टिट्यूशन 1 minus 2x square, that is x is equals to sin theta, and 2x square minus 1. For that we will take this substitution x is equals to cos theta. Now see this here. Next problem. If y is equals to cos inverse in bracket 2x in under root of 1 minus x square, find dy by dx. Okay, the problem. Here we will substitute these x is equals to sin theta and therefore theta is equals to sin inverse of x. म्हणून ते दोन्ही जे मी दाखवले तुम्हाला charts, formulas, tables, you have to remember all these, and using that here we substitute x is equals to sin theta and therefore theta is equals to sin inverse of x, and that's why y is equals to cos inverse 2 sin theta into in under root of 1 minus sin square theta. But what is the sin square theta? Is cos theta. That is a 2 sin theta into cos theta in under root of cos square theta. Then you will get cos theta. That is the cos inverse of 2 sin theta into cos theta. That is the cos inverse of sin of 2 times theta. Now see this here. What's the sin of 2 times theta? That is the sin of theta plus theta. And here you will get expansion of sin of a plus b expansion. Sin a cos b plus cos a sin b. परंतु इथे a आणि b दोन्ही कसे आहेत तर सेम आहे. They are theta and theta. That is sin theta into cos theta plus cos theta into sin theta. And that's nothing but the 2 times sin theta into cos theta. Therefore sin of 2 times theta is equals to 2 sin theta into cos theta. हा एक फॉर्म्युला आपण इथे अप्लाय केलेला आहे. Okay, 2 sin theta into cos theta means what? Sin of 2 times theta. And next here again we apply one more formula. Sin theta is equals to cos of pi by 2 minus theta. Y is equals to, instead of this sin of 2 times theta, we will write here cos of pi by 2 minus 2 theta. And again cos inverse of cos of pi by 2 minus 2 theta is nothing but pi by 2 minus 2 theta. And therefore here now, but what is the theta? Theta is a sin inverse of x. We substitute the value of theta. Now differentiate this with respect to x. Okay. We differentiate this with respect to x, dy by dx, ddx of pi by 2 minus 2 sin inverse of x. Derivative of constant pi by 2, that is a 0, and derivative of sin inverse of x is a 1 upon in under root of 1 minus x square, and this is a 2. Therefore it is a 2 into 1 upon in under root of 1 minus x square, and that's why the answer is dy by dx is equals to minus 2 upon in under root of 1 minus x square. Now the question number 5. Find dy by dx if y is equals to tan inverse in bracket 5x plus 1 upon 3 minus x minus 6x square. This example asked in March 18 for the March 3. Now the solution. Tan inverse in bracket 5x plus 1 upon 3 minus x minus 6x square, and this can be written as, this 3 can be written as 1 plus 2 minus x minus 6x square. Okay. Now we'll factorize this. Okay. That is a 2 minus x minus 6x square in this manner. Take minus sign as a common, and then here you will get, that is a 6x square plus x minus 2, 6x square, 6x square into minus 2, that is a minus 12x square. Then what are the numbers? Whose sum is x and product is minus 12x square. The numbers are, the factors are 4x minus 3x. Take from these two as a 2x common, then in bracket you will get 3x plus 2. Take minus sign, minus 1 as a common, then in bracket you will get 2x, 3x plus 2. Again take 3x plus 2 as a common, and the remaining terms, that is a 2x minus 1 in another bracket. And therefore the factors are minus in bracket 2x minus 1 into in another bracket 3x plus 2. Now here we can arrange the numerator like this. Okay, see this, the numerator. 5x plus 1 can be written as, 5x plus 1 can be written as 3x plus 2 plus 2x minus 1. We have the numerator 5x plus 1. हा आपल्याला न्यूमरेटरला होता, पण आपण तो कसा लिहिलाय? 3x plus 2. डिनोमिनेटर सारखं लिहिलंय, या टर्म सारखं लिहिलंय, या x सारखं लिहिलंय, y सारखं लिहिलंय ते. That is a 3x plus 2 plus 2x minus 1. म्हणजेच आपल्याला हा फॉर्म्युला इथे अप्लाय करता येईल. That is a tan inverse of x plus y upon 1 minus x into y. Okay. किंवा tan inverse of a plus b upon 1 minus a into b. And then we will have tan inverse of x plus tan inverse of y. Here tan inverse of 3x plus 2 plus tan inverse of 2x minus 1. Now differentiate this with respect to x. What's its a derivative? That is a 1 upon 1 plus 3x plus 2 into derivative of 3x plus 2. What is the derivative of 3x plus 2? The derivative of 3x is 3 and derivative of 2 is 0, and that's why we write here 3 upon 1 plus 3x plus 2 bracket square plus, again it's derivative of tan inverse of 2x minus 1, that is 1 upon 1 plus 2x minus 1 bracket square into ddx of 2x minus 1. Its a derivative is 2, derivative of 1 is 0, and hence we have here 3 upon, if we expand this 3x plus 2, then you will get 3 upon 1 plus 9x square plus 12x plus 4 plus 2 upon 1 plus 4x square minus 4x plus 1. And therefore the dy by dx is equals to 3 upon 9x square plus 12x, 1 plus 4, that is a 5 plus. Here again the that is a 2 upon, we'll add this 1 plus 1, that will be the 2. That is a 4x square minus 4x plus 2. If we take 2 as a common from the denominator, then we will cancel from the numerator and the denominator 2. Then you will get here 1 upon 2x square minus 2x plus 1. And therefore dy by dx is equals to 3 upon 9x square plus 12x plus 5 plus 1 upon 2x square minus 2x plus 1. Now the next example. If y is equals to cos inverse in bracket 1 minus 2 sine square x, then find dy by dx. This is for the March to July 18. Let y is equals to cos inverse in bracket 1 minus 2 sine square x. Cos of 2 times theta means what? Cos square minus sine square theta. ही सर्व cos ची family आहे बघा. And again cos of 2 times theta is 2 cos square theta minus 1. Again cos of 2 times theta is 1 minus 2 sine square theta, and that's also equals to 1 minus tan square theta upon 1 plus tan square theta. ही सर्व cos of 2 times theta ची फॉर्म्युला फार इम्पॉर्टंट आहे, तुम्हाला ते लक्षात ठेवावं लागते. Now next is a cos inverse of cos of 2x, and that is nothing but y is equals to 2x, and differentiate this with respect to x. Therefore, dy by dx is equals to ddx of 2x. Derivative of x is 1, 2 is a constant. That's why 2 into ddx of x. Derivative of x is 1. That is a 2 into 1, 2. And therefore, dy by dx is equals to 2. Dy by dx is equals to 2. Now, in this way, we have completed the how to find out the derivative of the inverse function and the rule for the differentiation of the inverse function. Now we'll see in the next video. Till then, goodbye.